What do you guys say we take a day off from proofs today? How about that, huh? Day off from proofs and just focused on algebra, even though your homework does have one proof in it, but not for today's notes. We're going to take a little breather from the proofs until tomorrow. And what we need to talk about today, we need to dive pretty deep into, is the isosceles triangle. Quick question, so I know we're all starting on the same spot. What's the only thing you know about an isosceles triangle from this unit? Two sides are congruent. That's it. You're going to know a heck of a lot more today, though. All right, two sides congruent. That's the only thing you guys know, or the sides are congruent. All right, well, first theorem here, right off the bat for today. Yes, the sides are equal, but ready? First theorem, first fact, so are the angles across from those sides. So everyone take a look at my first diagram right here. And I know yours is set up a little differently. I just cut up my notes a little differently than what you have on your page. Here's what the first theorem is saying. In an isosceles triangle, if the two sides are congruent, so are the angles across. So in this isosceles triangle I have for you guys, not only are AB and side AC equal, the angles across B and C are equal as well. How about that, kids, huh? How about that? So not only are the sides congruent, but the angles are congruent. Everyone all right? All right, now every time I show this, for some reason, everybody gets in the mindset, oh, it's always the bottom ones. The bottom ones in the triangle are always equal. No! Garbage! All right, it's not always the bottom ones. Watch. If you want, you can draw yourself a second triangle. It's up to you. I'm going to call this XYZ. Watch, it's not always the bottom ones. I'm going to say YZ is congruent to a ZX on my triangle. What are the congruent angles now? Angle X and angle Y. It's not always the bottom ones. It's always, ready? It's always the ones across from the congruent sides. Okay? Everyone good then? Do not just assume it's always the bottom ones, please. So again, if the sides are congruent, so are the angles across. Ready? Flip it now. If I have two angles are congruent, what else has to be congruent now? If I have two angles in the same triangle congruent, so are the sides across. And that is all the second theorem is saying right there. All right, that's all this second theorem is saying, is if two angles are congruent, the sides opposite are congruent as well. That's all that's saying, okay? So we can go back and forth. Bottom line, you have two angles or two sides, find what's across from them. They'll be congruent too. Okay, find what's across from them. All right, that's really it in a nutshell for today. I just need you to learn some vocabulary terms of an isosceles triangle. Okay, so if you guys go to the next page of your notes there, we're going to learn different parts of an isosceles triangle. All right, real quick on my diagram, I have AB and AC marked. What are the congruent angles? B and C, the angles across. So if you want to mark the angles across congruent, that's fine too, just to get in the habit. If I see two congruent sides, the angles across are equal. All right, what are the names for all these? All right, let's start with angle A, the non-congruent angle. Do I want to say non-congruent angle all the time? No, let's put an actual name to it. So what is in an isosceles triangle, the non-congruent angle? Anybody know before I spot you the first letter? Anybody want to drop knowledge? The non-congruent angle in an isosceles triangle. Let me drop you a first letter. V. Vertex angle. There we go. Vertex angle. The non-congruent angle in an isosceles triangle is called the vertex angle. All right, so I'm going to start labeling them here as I go along. So there's the vertex angle. Remember, does it always have to be on top? No, it's wherever the non-congruent angle is. All right, next one, number 2, the equal sides. The two sides that are equal in an isosceles triangle. Called L. I'll spot you the L. Good guess, no. We talked about them yesterday in a right triangle. Legs, yes. In an isosceles triangle, the two congruent sides are called the legs. My next hint was going to be you have two of them and you walk with them. Maybe I would have gotten more people. The unequal side, the side that's not congruent to the other two, the outcast of the sides. Maybe some of you can relate to that. Moving on. Ready? The unequal side, I'll spot you the B. What do we got? Base. There we go. It's called the base. And can you get out of the middle school mindset? Base does not equal bottom anymore at the high school level. Base does not equal bottom. Okay? Get that out of your mind. It's wherever the unequal side is. And then what about the two equal angles? So in our case, B and C. The two equal angles. I'll help you out. What's in between the two congruent angles? What did we just call that side? In between the two congruent angles. That's called the base. So these are the base angles. Okay, base angles. The two congruent angles are the base angles. All right, everyone good with the vocab? If I have two sides congruent, the angles across are equal. If I have two angles, the sides across are. Ready to do a problem here with me. And then you're going to go on your own, and we're done already today. Done! Here we go. Let's see if we know what we're doing here. Everyone see my beautiful diagram? I have sides and angles marked for you. Congruent. Hey, anybody see a couple isosceles triangles in that diagram? Everyone just take a quick peek before we answer the questions. You guys at home see a couple isosceles triangles in that diagram? All right, my first question. Name an angle that's not marked already. You're not allowed to use a marked angle. Give me an angle that should be equal to angle R that's not already marked. Use our isosceles triangle facts here. And I'll call on somebody here in a second, but give you a second to look at the diagram. Angle R is congruent to what other angle in that diagram that's not marked already? And if you don't know, let me know. I'll help you through it. Here we go. Angle R congruent to Quincy. Here we go. Angle R congruent to
Angle B.
Angle, oh, I need more than V. There's a lot of V's there that could be angle V. I need you to get specific for me.
Angle RVU.
R, there you go. I like that heck of a lot better. There we go. RVU. Everyone see that angle? I'll mark it in black as well. This one right here. Why is he correct? Here's the theorem we're going to write down that will also be written down tomorrow when we start proofs with isosceles triangles. Ready? Why is this true? In a triangle, and yes, we always have to start in a triangle because if you do a quadrilateral, a pentagon, octagon, this doesn't work. Only in a triangle. So in a triangle, congruent. Did we know the sides or the angles were congruent in this one, in this triangle here? Okay, so that's what, thank you, the sides. So in a triangle, congruent sides are across from, how do you think I'm going to end this? Congruent sides are across from congruent angles. Good work, kids. Good work. Please ask questions before I move on. Everyone all right where angle RVU came from? What triangle we're talking about? All right, next up. Go ahead.
Can we say that congruent sides imply congruent angles, or is that not specific enough?
No, you have to tell me across from, so I know that you know to look up. The cross from's the big part. Okay? Ready to go? Next one, RT. Everyone take a look. RT. Name another side congruent to RT. So can you find a single triangle that contains RT that might be isosceles? All right, let's see what you got. RT congruent to. Who we got in here? Sabrina, what do you got? RTN. TS. Good job. RT congruent to TS. Real quickly, if you're wondering, everyone look at triangle RTS, the big one. It's isosceles because these two angles at the bottom are congruent. So Sabrina said the sides across have to be equal. TR and TS. So my reason, here you go, in a triangle, congruent, but now I'm going to start it out with, what was I given in this triangle? Angles. So I'm going to say in a triangle, congruent angles are across from congruent sides. So I always start the theorem off with whatever I was given, whether it be angles or sides. Guys are doing a nice job here so far. All right, VW. VW. Find a triangle that has VW as a full side, and hopefully it'll be part of an isosceles triangle. VW. What do you got for me? Ooh, I'm going home now. Hated. VW and?
BW and WS.
WS. Everyone see that isosceles triangle right here across from those angles or congruent sides? Okay, so let's write it, finish this up. In a triangle, congruent, what was I given in this one, guys? Angles again, congruent angles are across from congruent sides. Okay?
So could you be given a triangle where there are the two congruent angles at the bottom, and would that be enough for you to prove that they're isosceles?
So you're given this right here?
Yeah, if you were given that, would that be enough to prove that it's isosceles?
Yeah, that's isosceles. Definitely isosceles. Yep, absolutely.
The definition of isosceles is only, you can only find that if you say that two sides are congruent.
Yep, now we're expanding that. Now if two angles are equal, it's also isosceles. Okay? And also, while I'm on this topic, real quick, before I let you go to the algebra questions, I don't care what is all. Everyone agrees that my original triangle was isosceles, right? All right? So if I put a random line in, I just drew that line down, these sides are still equal. Okay? I don't want you guys to think this is also equal to everything else. It's in the triangle, in this single triangle right here where the two angles are, you have to look opposite. All right? Don't think this dotted line I just put in is involved at all. All right? All right, you guys have two algebra questions. Yes, Kyla, go ahead.
In an equilateral triangle,
Yep.
all the angles are congruent. So how would you know the difference if it was an equilateral triangle versus an isosceles triangle?
Okay, equilateral is isosceles. As long as it's got at least two angles congruent, you can call it isosceles. Equilateral, that third angle is congruent to the other two. So if it's equilateral, you could still call it isosceles, but a better name for it is equilateral. Okay?
So,
Okay.
the theorem still apply?
What's that? Oh, yeah. Yep. Mm-hmm. Any other questions there, guys? Good discussions here today. All right, you got two algebra problems left on the back. I'm going to give you guys a few minutes to complete them. I'm going to put the answers up. And if there's no questions or concerns, we're going to start the homework. Okay, so start those algebra questions on the next page that deal with isosceles triangles.
Why did you want like given any numbers to look up?
You're not given any numbers? The packet has numbers, right? No? Nobody was gonna tell me this? All right, yeah, I need to give you, no,
Yeah, there's just an X and a Y. I figured it was just a challenge problem.
no, it's,
Yeah.
no, sorry, that should be, no, there should be a 55 in the bottom left, my fault.
Okay.
See, that drives me nuts. Period 1 never said a word. So how did they get through this? Unless they waited until I put it up there. It should be 55 in the bottom left. Sorry, guys.
Well, I was going to do, I did x plus 2y equals 180, and then I did 2y equals 90.
X plus-
1/2 x. And then I solved it from there, and I substituted y in for 90 plus 1/2 x, and that's what I was gonna do. Would that have worked? What did I do it for?
I'm not too sure.
It's just.
We also don't have the congruent side markings on number 2.
Oh, all right, now you do. Okay, I'll start putting the answers up. If you guys are good with them, you can go on to the homework. If you're not good with them, let me know. We'll figure out where you went wrong. So if you guys are good with those, we can go right to the homework. If you want to know where something came from, let me know.
I've got a question on the homework.
Yep.
First night, I just started number 7.
Yep.
I understand that based on the markings that angle A and angle C would be congruent.
Yep.
I just don't know what to do with that.
Remember what we used, what we just wrote down in the problem where we're finding sides and angles. So start it in a triangle, congruent sides or congruent angles, depending on what you're given. Remember, in a triangle, congruent sides are across from congruent angles. Okay, that would be your reason for saying the angles are equal.
I mean, I'm a little confused. Why do you even need to say that, why do you even need to say that angle A and angle C are congruent? Can you just say
You can do
that
side.
angle?
You can do side.
Oh, wait, no.
side.
Oh, sorry, it says, I didn't realize it said triangle ABA, that was an angle ABA, ABE.
You don't have to because you can get away with doing side angle side. You don't even have to mention that A and C are equal.
I misread what I was trying to prove,
Okay.
sorry. Sorry again, but,
Yeah, I'm
it
listening.
says, in the answer it says something about side angle side. I can understand how you can say that BE is equal to BE,
Yep.
but then it would just be two sides and one angle, but the sides wouldn't be next to the angle.
But the angle that's getting bisected, though, those two angles that are congruent, they're in between the reflexive side and the given sides. Right? This is what you have the reflexive side. This was given right here to you. And you have the congruent angles in between, that side angle side.
So you wouldn't even need to say anything about angle A and C.
You could. Then you would use angle side angle, angle side. You could do it. It's just another way of proving the triangle's congruent. I just wanted to point out you didn't need to say anything about the triangle being isosceles to do the proof. You could.
I thought we were always supposed to use every part of the givens.
What's that?
I thought
We are
using the givens.
we are using every given.
Okay.
What given don't you think we're using?
Never mind. Sorry.
Okay. We're still using all the givens.
Do you have to write in, like, as a statement that the lines are congruent because it's an isosceles triangle?
No, usually usually what should happen is they'll tell you in the givens triangle ABC is isosceles with these two congruent sides. So no, you don't have to write that in. That's part of the givens.
Yep, go ahead, Rudy.
So how would you say like say definition of isosceles to say like,
No, you don't even. That's part of the givens in that case. That those two. Because if I'm going to say triangle ABC is isosceles,
Mhm.
I got to tell you what two sides are equal. You can't just look and assume it's the left and the right.
yeah,
So that is AB being congruent to BC is part of that given that it's isosceles.
oh, so if there's markings on the diagram,
Yep.
that's part of the given?
If it's saying it's isosceles, yes.
Okay.
Yeah. Usually, what it should say is triangle ABC is isosceles with AB congruent to BC.
Okay,
Yes,
so
that-
technically it is
Yes,
part of it.
correct. Yep.
For this one. You're not squaring everything on this side.
Oh boy, there's no square in there. It's called factoring.
I think so.
All right. Yep. Move that 24 over. Two numbers that multiply and add. Yep. Warning everyone, you're going to get a factoring one. We're not going to panic. We're not going to cry. We're not going to start sweating excessively. We're going to factor it. Yep. Go ahead, Hannah.
Could you use angle side angle for that?
As long as you said that angle A and angle C were congruent, because in a triangle, congruent sides are across from congruent angles. Yep, absolutely. All right, guys, nice job today. Do not skip that factoring question. You guys have 2 days to do it. Due on
Which one
Thursday.
is the factoring question?
I think the last one, right? The very last question.
I'm sorry.
There's one on 21.
Yeah, I was gonna say, what are you
Okay.
supposed to do with 21 then?
It has an x squared with it.
No, but
No,
there's,
just
I don't
two
think there's any way. Yeah, two variables.
Okay.
So it's not, you just add this, like, the 4x plus 20 and the 4x plus 20 to get 180.
I think there's a way around not having two variables though.
Yeah.
I have no clue what it is.
What's the question here?
There's 21 on the homework.
So you got one is it one triangle?
Yeah.
Okay, what else you got with it?
The vertex is 52 degrees.
What's that?
The vertex is 52 degrees.
Vertex angle 52. And then what they give you one of these angles down here is what?
One of the angles is 6y minus 2, and the other is 4x plus 20.
Okay, what do you know about those two angles?
They add up to 128.
Well, no, they're congruent, right?
Yeah.
So if you want to, if that angle's 4x plus 20, why don't we call this angle 4x plus 20? Right, because they're equal to each other. Now you can set them, you can add all of them up and set them equal to 180.
That's not my problem.
Right?
I didn't think about that.
Okay? And then once you find x, plug it back in right here for 4x plus 20. Find out what that angle equals, and then set 6y minus 2 equal to it. Okay, so no reason to have an x and a y in the same equation. All right, ladies?
Sweet.
All
Have a
right.
nice day.
Good question. See you guys Thursday. Caroline,
Yeah,
how the heck you been, huh?
good. Doing math.
Good to see you back.
Me too.
Refreshed, ready to go.
Yes.
You guys are back for a day, and then I don't see you till Friday. It must be nice. Rough life you guys live. Rough life. Oh, and then back to spraying these things down.
Katie Bailey.
Gentlemen, welcome back.
Good to be back.
I'm sure. I'm so happy as well. You can't tell, Sophia. I get to spray desks down again, wear a mask while I teach for 3 periods in a row. Oh, I'm all, yeah, it's good times. You guys come back a day, then you get a day off. I tell you, you kids got it made. Hello, Liz. How are you? I'm doing well too. Thanks for asking. Kian, hello, welcome back. They're all done there.